Hello and welcome to Forrester High School Maths Department's National 5 Math Support Materials. My name is Mr. McDonald and I'm going to be talking you through your topics today. Today's lesson is going to be all about being able to find sector area and understanding terms such as arcs, sectors and internal angles. In the last lesson we spoke about arcs and also internal angles. Today it's more the turn of sectors. So just a little bit of circle vocabulary. An arc length is a distance around the outside the circumference of a circle, but only part of that circle. A sector area is the same thing. It's the area of only a part of the circle. This sector area here is highlighted in green, so you can see exactly the area that it covers. The internal angle, remember, is the angle at the center of your sector, and it's also the angle that you use to calculate the length of an arc as well. So hopefully you have those three things in your head from last lesson, and we can move on and calculate some sector areas today. Okay, so the first thing we need to know before we calculate the area of any sector is the sector area formula. Sector area formula is SA, which stands for sector area, is equal to angle over 360 or theta over 360. Remember, this means our internal angle. And then multiply that by pi r squared. The pi r squared part relates very closely to what we know from National 4 is the area formula. Okay, so it's just some fraction of the circle multiplied by the area formula gives you that fraction, that slice of the circle, which is your sector area. So our first task here is to find the sector area of this circle. Our internal angle is 285 degrees. That's going to be standing in for our theta in just a second. And our radius here you can see is 7 centimeters. That's going to go in that part of the equation. So just to change to a pen, here we go. Sector area, putting in my numbers, is equal to 285 for my internal angle out of 360. That's what a full circle has in degrees. So that's the fraction of your circle that you're going to be finding the area of. Then we're multiplying that by pi and multiplying that by the radius squared. Because this is a calculator question, we can go ahead and put this into our calculator and get a final answer. We get a final answer of 121.87. Now remember, because this is an area, it's a space in 2 dimensions, we have to give our units in 2 dimensions as well. So I'm working with centimeters squared. That's what that little 2 stands for. It's a measurement of space in 2 dimensions. Okay, so here's another quick example. I have a sector area here, a smaller slice of the full circle this time. Its internal angle is 86 degrees, so that's going to take the place of theta when I do my substitution. And I'm told here that the diameter is 40 millimeters. Now, my formula is using radius, so we're going to have to figure out what the radius is just before we start this calculation. So I'm just going to put r for radius, and then I'm going to half my diameter, because remember the diameter is the full distance from one edge of the circle to the other through the center. The radius is just from the center to the outside edge of the circle, so it's half the size of the diameter. So in this case it's 20 millimeters. Okay, so my substitution stage, I write down SA, which stands for sector area. My angle goes on the top, that's my internal angle. 360 goes on the bottom, that's how many degrees in a full circle. I'm going to multiply that by pi. Remember, if you're using a calculator that's a scientific calculator, you can use the pi button. If you're using a calculator that doesn't have a pi button, then go ahead and use 3.14, which is an approximation. It's close enough for the purpose of this activity. and then I'm going to do 20 squared, because that's my radius squared. Don't forget that squared sign. I know in the last activity you didn't have that squared sign. You were doing pi times d, so you didn't have a squared number on the end. Just be careful that for these sector areas you always have a square number on the end. So my final answer is 300.2. We have to be careful here because this is not in centimeters, it's in millimeters. We also have to be careful because it's an area, so it's going to be in millimeters squared for a 2D shape. Okay, so our final example here is one of those ones that the SQA likes to try and trip candidates up with. This is finding the sector area of a circle, but without a calculator this time. So we are going to say that pi in this example is kind of equal to, but not really. It's approximately equal to 3.14. All right, and again, when the SQA asks you this question, they say take pi to equal 3.14 in this case. All right, so our sector area is going to be equal to the internal angle. I'll not highlight it this time. You can probably see that it's 210 degrees over 360 degrees pi times the radius squared, which is going to be 6 squared. Okay, so first things first, what we need to do is we need to simplify this fraction here to make it something that I can manage. All right, and it probably wouldn't be a bad idea to figure out what 6 squared is as well. Right, starting on the fraction, 210 divided by 360. I know that there's a common factor of 3 between 21 and 36. So between 210 and 360, there's going to be a common factor of 30. So divide 210 by 30, and you get 7. Divide 360 by 30, and you get 12. 7/12 times pi times by 6 squared, which is 36. Okay, our next step is to make this simpler again. Remember, when you're multiplying three numbers together, it does not matter what order you multiply them in. So I'm going to multiply this fraction here by this number here. I'm going to forget about pi just now because that's the decimal number that is a little bit more tricky to deal with. So my sector area is 7/12 of 36. Well, 1/12 of 36 is 3. 7/12 is going to be 3 times 7. That's 21. Pi, in this case, we're going to be taking it as 3.14. So I'm doing 21 times 3.14. Okay, so how am I going to approach 21 times 3.14? I'm probably going to do 20 times 3.14. And then add on at the end another 3.14. And that'll give me 21 lots of 3.14. So to multiply by 20 is nice and easy. All I'm going to do is I'm going to multiply by 2 and then move my digits one place over the decimal point to make them bigger. So 3.14 times 2 is 6.28. So 20 times 3.14 is 62.8. And I'm going to add on to that 3.14. Because there's nothing above my 4, I'm going to make a placeholder here as well. Add those up. 0 add 4 is 4. 1 add 8 is 9. 2 add 3 is 5. And 6 add nothing is 6. So my final answer is the sector area of that slice, that sector up at the top left-hand side of the screen is 65.94. And my units are centimeters squared because we're looking at a 2D area. And that's it. If you can remember those steps, you can take on just about any SQA question about sector area or arc length. I have to say, if you made it to this point of the video, very well done. Remember, with your assignments, you're always welcome to ask me questions, either via email or show my homework. In next week's assignments, we're going to change that up a little bit, but I'll talk to you more about that in next week's assignments. Remember that you can do this. All right, it may take a little bit of guidance from me. If you want to ask me questions, that's fine. It may take a second or even third attempt, but I'm sure that you are able to do this if you put in the effort. Remember to upload a picture of your work onto Teams, and very well done for getting to this stage in the video. Good job. Well done, Nat5s.